So in the interest of time, we did not schedule a break, and we want to have the next speakers and moderator to come up. So I know Paul Cook is here, and Franz Spivey Weber, Kala, and Rhodes. So if you can come up to the podium. So I want to introduce Paul Cook. He's the general manager at Irvine Ranch Water District. I have to be on my best behavior because they're one of our oldest, going back to the beginning of NWRI 23 years ago. They've been one of our members for many years, been a great partner of ours. Paul, I'm going to turn it over to you.
Thanks, Jeff. Making it up here. Well, good morning, everybody. First of all, I want to welcome you if you're new to the water industry. Welcome. It's a fascinating and, dare I say, a very cool industry these days. And if you've been around for a while, congratulations, you're finally cool. The drought has really brought a lot of attention to our industry. I think it's in a very good way. People are paying attention to the supply issues, the water quality issues. So a forum like this seems to grow every single year, and for good reason. So really looking forward to our program today. In this particular session, we're going to talk about urban water sustainability. So I want to start off by introducing Dr. Kala Vairavamoorthy. How'd I do? I got the thumbs up. We did not practice that at all. I'll go with Kala for the rest of the time, though, so that's okay. Kala is an expert in urban water issues, and who has worked to create clean and sustainable water and sanitation systems through programs with UNESCO and the European Union. He currently directs the University of South Florida School of Global Sustainability. He's led groups of researchers studying the future of sustainable water systems for cities and how urban areas might respond to water issues in the face of climate change and population growth. His research includes the development of new techniques for the flexible design of urban water supply systems operating under uncertainties associated with global change. He earned his Bachelor of Science in Civil Engineering from King's College, University of London, has his Master's and PhD in Environmental and Water Resource Engineering at Imperial College, University of London. So please join me in welcoming Kala Vairavamoorthy.
Okay, good morning, everyone, and thank you very much for pronouncing my name correctly. That's quite a feat. Usually that doesn't happen. Let me just... Okay, so what I'd like to talk about today is really some of the changes that the water sector is going to have to make in order to respond to some of the global change pressures that we're likely to be facing. We have very traditional water systems, and Jeff alluded to that earlier. We have these linear systems where we take water from afar, we move it, a lot of energy involved in moving it. We produce one quality of water for drinking, and we use that for everything. We tend to use the water once, and then we throw it away. And this is traditionally what we've done, and it's been the approach that we've adopted from around the 19th century, and we still continue to do that. And we actually promote this type of approach. I do a lot of work, by the way, in developing countries. Most of my activities are in developing countries, and we've been promoting this type of approach in many developing countries. And frankly, it's unaffordable for most countries, probably for about 2/3 of the planet. And we see that we haven't been very successful in terms of providing access to water and sanitation in many countries because we push these linear use once, throw away systems. So what I'd like to talk about is really some of the changes that are required in order for us to sort of try and transition our water systems away from these traditional approaches. I think there are many ways that we can change the way in which we do our water systems. But for me, one of the sort of big transitions we need is really changing management. And for me, the most important thing is a change in perspective. We tend to think, as I said just a minute ago, that we have to use potable water for everything. We also think that with any growth, we just need to keep adding regular additions of water. And this leads to very intrusive, capital-intensive projects, very energy inefficient, I would say. And so I think we have to start moving away from that and focus much more on the productivity of water. What is it that we want the water to do for us? And when we start thinking about the productivity of water, we start sort of thinking more about investments in efficiencies, investments in looking at how to match the quality of water for its intended use. And we start looking at a portfolio of sources. So, of course, for drinking, we need a very high-quality water for drinking and cooking. But for conveying feces, do we need water at all? And if so, what type of grades of water would be appropriate for that? For irrigation, for plants, how can we be more precise in the way we apply water to those plants? And again, what type of qualities would be more appropriate? And the most important thing for me in terms of this sort of productive use is to change also our perspective in the way in which we view the water cycle. We tend to view the water cycle in terms of the areas we come from. So if we're drinking water people, we look at the drinking water side. If we're wastewater people, we look at the wastewater side. If we're interested in stormwater management, we look at stormwater. But once we start looking at the water cycle in its entirety, we see that there are many different flows of water, and each of these flows have different grades. And each of these grades of water are very useful. They can be used with or without treatment. But it's this sort of integrated perspective that opens our eyes to thinking about how we can get the greatest productivity out of water. If we look at, for example, leakage and demand management, leakage is very expensive water. It's been treated, there's a lot of energy embedded in that water. And if we have a growing demand, the question is, do we look to import water from afar to meet that growing demand, or can we minimize some of this leakage, and then that becomes a potential water source to meet those growing demands? When we look at grey and black water, they have possible uses within the water cycle with treatment. So again, how can we match those different grades of water for different uses? And what's critical for this is really a sort of a systems approach. Okay, viewing the water cycle in its entirety and then sort of having a very sort of systemic perspective of how water flows around this system. And we've been doing a lot of work in developing sort of systems models, simple sort of mass balance and contaminant flux models, based on nested approaches. So we look at a house and the flows within a property, and then we look at a development, and then a larger development, and then a town. And what you're able to do with this sort of systems approach is that you can start to connect the dots. You can connect these different grades of water to their different intended uses. And very often, by applying this systems approach, you can actually meet many of the growing demands for water without importing additional water. I'll give you an example. We recently did a project for the World Bank where we were asked to look at, water issues in Nairobi, in Kenya. And Nairobi is rapidly expanding its population. It's going to double in the next 20 years. And their solution for meeting that growing demand was just to import water from afar and bring it to the city. And this created a lot of problems, mainly because in Kenya, the government had given a lot of autonomy to counties, and the counties where they wanted to take the water from said, you're not going to touch our water, and it became a transboundary issue. So we were brought in and we worked with our East African partners to look at what was possible, and we developed a simple systems model. We looked at their traditional solution of just going for more imported water. We looked at the unit costs. We can do that sort of simulation. But then we started looking at alternatives. And we started to find that many of these alternatives not only could postpone investments in future infrastructure, but they could also bring down the unit costs of water. So these sort of systems approaches allow you to try different scenarios to see what's possible. And of course, we looked at sort of more exotic types of solutions where we had more sort of reuse and recycling, and then the energy footprint starts to increase. But the fact is that we can really sort of simulate different types of conditions and see what would be the best and how to optimize that. And, we've published this in a book, but the outcome of this work was really the government of Nairobi changing their perspective, changing the way they were thinking about how to meet the future of their water demands. And you see this in other places. I was involved in a project in London. It was the Thames Gateway development, where they were developing 160,000 houses. It was one of the largest developments in Europe. And it's just on the edges of London, around the Docklands towards the east. And they wanted to respond to this development by making it water neutral. They didn't want to import any new water to this development. And they actually found, they looked at 5 scenarios, and they found that 3 of those scenarios could really deliver on that sort of water neutrality concept. And it was really about looking at efficiencies in existing properties and freeing up water, looking at developing more sort of sustainable properties in this development so the demand for water reduces, and then looking at reuse and matching different qualities for different uses. So you're seeing this type of thing happening all over the place. When we think of technology and how we need to transition in the area of technologies, again, I don't want to talk specifically about technologies. I'm sure there'll be presentations later in the day about technologies, but of course there are huge innovations taking place in the area of membranes, for example, super smooth membranes, membranes that don't biofoul. So there's lots of innovations taking place in this respect, and the scalability of technologies is also something that we're seeing, so we can have both on-site and then sort of very centralized types of approaches. But for me, the discussion on technologies, again, is around perspectives. And what you're finding is that, people are starting to change their perspectives. And again, coming from a developing country, one of our biggest challenges was how we deal with sanitation. Sanitation was always lagging behind. We weren't dealing with the issue of sanitation. So people have started to say to themselves, traditionally we would look downstream up, see these used water streams coming out of properties, and we would look at it as a burden. How do we deal with this crap? And I mean that literally, right? But now people are saying, well, actually, this is a resource. There's lots of things embedded in this stream. There's biomass that has a lot of calorific value. There are nutrients embedded in this stream. And there's a lot of water embedded in this stream. So how can we somehow capture as much of that value out of these used streams? And this is how we're trying to address the sanitation challenge in many developing countries. And you see the language changing. People are starting to use words like beneficiation. How can we get the maximum benefit out of every drop of the water? And you already see this type of thing happening. And of course, this area, West Basin Water District, is very innovative, very progressive. It's been doing this for some time, where it takes its waste streams and it uses innovative technologies to create what they call designer waters. They plug and play different technologies and they produce different grades of water for different uses. So they're looking at their waste streams really as a valuable resource. In South Africa, for example, where very early they made water a human right, so everybody had an entitlement to water. They couldn't meet the demands of the poor people in the peripheral areas because water was very scarce. And they had huge industrial water demands. And so what they did was they deregulated, they allowed the private sector to enter into the market. The private sector was then able to take these waste streams from the city and again, using different innovative technologies, create different grades of water for different industries. And the industries actually got water a lot cheaper. So you see that happening. On the other side of beneficiation, where you're looking at biomass production, you're looking at nutrient recovery, again, we see a lot of this happening now. And it wasn't happening some time ago, but it seems to be happening much more now. When we look at biogas production, there's a lot of innovations in not just looking at electricity production, but also looking at heat generation from the production of energy. And if you look at the picture on the side, it's a small picture, but it's really a energy production system. It's called the Omni process, which is being implemented in the Senegal, which will be the first sort of biogas electricity generation system in Africa, but also in Uganda they're looking to implement that, and it's being funded through the Gates Foundation. It's where fecal sludge is being really used to produce electricity, which is generally very unreliable in some of these areas. So they're seeing the potential to sort of extract both electricity and heat from the biomass. Nutrient recovery, of course, is now becoming very popular. Here in the United States, the Stickney plant in Chicago, the largest wastewater treatment works in the world, is going to be implementing an Ostara system which sort of recovers struvite from the wastewater stream. So, the phosphorus is being recovered, and they say the payback for that is about 5 to 7 years. But again, in developing countries, you're getting small-scale entrepreneurs who are entering into the market and developing sort of units that can extract fecal sludge from septic tanks and from wastewater treatment works, and then, sanitize that sludge, dry it and pelletize it and bag it and sell it as fertilizers for industry. And you're seeing that the Ladapha machine is probably the most famous that does that, but you also have very similar types of systems taking place in India. So this idea of productive use and beneficiation, this idea of trying to get the best out of your waste stream, is now sort of having an impact on language. What you're finding is that people are moving away from talking about water treatment and wastewater treatment, and now they're talking about water machines. A machine where different grades of water enters into this machine. You turn the handle and you can produce different qualities of water for different types of uses. You turn the machine and you can produce energy, both electricity and heat. You turn this machine and you can produce sanitized sludge or nutrients. And people are even arguing that in the future, these water machines may be primarily designed around energy production. They may be optimized to produce energy, and the byproduct might be water. And this type of thinking is really starting to sort of grow, particularly in the international community. And what's interesting is that when you start wanting to do some of these clever things with water, reuse, recycle, energy recovery, etc., scale starts to be important. You don't want to move water long distances away and then try and bring it back because water is very heavy. If you're looking at co-digesting with solids, you don't want to move solids long distances. If you want to recover heat, you don't want to move heat long distances because it loses efficiency. And people are now coming up with sort of ballpark figures of around sort of 30 to 50,000 inhabitants where these machines are actually very effective and they can be optimized. Of course, when you do the maths, the size will come out, but that's the sort of rule of thumb that people are working to. And from a developing country, people are very interested in these machines because most of the urbanization that's taking place is not taking place in big cities. It's taking place in villages that are becoming towns and cities. And traditionally, we would have gone for investing in large centralized infrastructure, anticipating growth. But now what they're realizing is that with this sort of more semi-centralized clustered approach, as an area grows, you can start adding modules, okay? So you can have this sort of incremental growth pattern through this sort of semi-centralized approach. And so you can follow much more clearly the trajectory of your urban development rather than sort of over-designing and anticipating growth. Of course, these distributed systems also provide a high degree of resilience. If there's any sort of extreme event, the disturbances won't propagate because they're distributed. So that's an added attraction with these systems. And you see this already happening. This is some work done by a colleague of mine in Germany, TU Darmstadt, Peter Cornell, and he sort of built a sort of a water machine in Qingdao in China, serves a population of around 12,000. There's source separation in terms of grey and black water. Food waste is also being used to generate energy, and so it's sort of net energy positive. Treated grey water is being used for toilet flushing, treated black water for irrigation, street cleaning. The heat that's generated from the biogas production is being used for district heating. So this type of thing is already happening. This is an example in Germany, in Hamburg, and they've actually trademarked this. This is a small demonstration site where, again, they're trying to provide a total solution to urban developments, and this is just a demonstration project, but its primary aim is to bring in people from developing countries and for them to export this technology for new types of developments. They recognize that, the big municipalities and water districts can't supply all of their urban dwellers, and so they want to try and sell this complete solution as a product. Again, it's sort of closing the loop both in terms of water and energy. And you've got other examples. I don't have time to talk about it, but really, you're seeing this really at the moment in the peripheral areas of urban areas, where they're taking people off the grid. And so again, we were asked by the World Bank to look at a couple of emerging towns in Uganda, and we applied these types of approaches. And you can see here, very traditional type of trajectory. What happens is you have a centralized core of infrastructure which was usually laid by the colonialist, in this case the British, and as the urban area grows, this sort of network starts to grow and the centralized system sort of takes a life on its own. So what we thought was, what if we were to ring fence this centralized infrastructure and around it build these sort of semi-centralized clusters? And so we went through a lot of designs and we created a semi-centralized solution, and we compared it with a centralized solution, and what we found is that this much more decentralized sort of clustered approach to urban water management was actually much more cost effective. And now the World Bank is looking at instigating a pilot for this type of approach. So this is a sort of way that people are thinking now. I'm not saying that, you know, decentralization and sort of distributed systems is the way forward. It's not a religion. It's really a continuum of options that we're looking at. In some cases, centralized would be better. But we have large centralized infrastructure, and then the question is, with that centralized infrastructure, are we stuck with it, or can we sort of transition away from it to a more decentralized approach? But the problem is, traditionally, what we do, and it's very similar to what I just said with the Ugandan case, you have a centralized system, and as your area grows, what you assume is that your centralized core can never change, and you just sort of expand it. You reinforce and expand it to meet the growing demand. But what if you said, well, no, I don't want to maintain a centralized system, and I want to sort of decouple my centralized system, and I want to move to a much more distributed system? How would you do that? So we've been working on the application of some optimization techniques where what we've done is even if we have an existing system, we assume that the system doesn't exist. We then optimize a new system from scratch, and we might create some sort of distributed system. And then what we try and do is we try and take pieces of the old system and embed it into the new system and see what the impact of the old pieces being embedded into the new system are. And if they have no impact or a marginal effect, those elements will be kept. If they are very detrimental to the development of this new type of system, we then say, you know, we have to transition out. We have to sort of somehow decommission these over time. So, for example, so this is the sort of thing that we do. So, for example, this is your centralized system, and you want to morph it to a much more decentralized system. You know, how can you do it in stages? So you keep adding elements to your network, but over time, you end up with a sort of a decentralized system. So you're morphing almost seamlessly from a centralized to a decentralized. The last thing I wanted to talk about is really something that actually I worked with Jeff on. We wrote a proposal recently looking at how to transition, and it's this sort of innovation continuum. It's a very simplified version of it. But what's clear is that the water utilities and universities are really at sort of opposite quadrants. You know, the water utilities are saddled with aging infrastructure. They adopt practices that outlive their usefulness, and they sort of have sort of obsolescence there. And as an industry, they tend to be very risk averse. They have these perceived risks associated with taking on innovations, and it's around, you know, reliability of the technology, the environmental impacts of the technology, how would the public accept that technology. At the same time, they have a high degree of urgency because they have customer demands, they have reliability challenges, and their response is to spend heavily on sort of status quo technologies. Universities, on the other hand, are doing their fundamental research, but they have no urgency. You know, I'm an academic. We live in an environment where we have no fixed schedules, no concept of deadlines. And another issue, I mean, it's true, another issue is that we don't really appreciate very much the whole notion of demand-driven research and applied research. And our metrics within the university don't really encourage that. So you have this gulf between these two sectors. And so the question is really, how do you move them much more closely together? And I think with utilities, we need to encourage them to invest more in pathways and capacities that accelerate fundamental change. And, you know, really, we need to have more research on how to sort of understand the risks that these utilities feel that they're under and assuage them and their fears and threats that arise during the transition process. We need to understand some of the organizational and industry sort of barriers to innovation, and we need to bring the utilities much closer to stages of development. So what really I'm saying is that there needs to be greater research on how to create a more innovative culture within the utilities. There are some good examples. For example, here, Orange County, the West Basin, and actually one of my PhD students, who happens to be the Chief Technical Officer for WEF, is actually looking at what are the ingredients of good leadership of those innovative water utilities, and how can we capture that in a bottle and sort of try and spread the message. Universities, on the other hand, I think they need to work with a greater sense of urgency, and we need to close the links between the practical needs of the water. We need to sort of closer their links with practical needs of the water sector. And I think funding agencies need to encourage much more, greater amount of demand-driven research. And I think also we need greater research on how to do research that has greater impact, that has greater uptake, and really how to maximize the upscaling of pilot projects and demonstration projects. I ran a very large project in the European Union a few years ago called Switch, and it was really all about how to maximize the uptake. And the project was demand-driven, so from the sort of concept stage of what we were going to do, the stakeholders were involved, okay? They actually conceived what research needs to be done, and the academics responded to that, and we were always in partnership. And that sort of brings me to my next slide, which is really, there are other players in this continuum, okay? You've got the research foundations, you've got engineering and technology companies, and really the question is how to bring all of these actors together. There are gaps in this sort of in this continuum, and that sort of breaks this virtuous cycle. So the question is, how do we bring all of these actors together within a collaborative platform to sort of move forward so that innovation starts to move much faster? And LIFT, which is a WRF program, is a very good sort of example of this, where it tries to bring these different actors together to try and promote much greater innovation. I think my time is up. Or do I have one more minute? Okay. Can I just conclude? Sure. So I just want to, just to conclude, I think, what I wanted to really present to you is for me, everything is about transitioning perspectives, okay? We have to think much more about the productive use of water. We need to look at the water cycle from a much more of an integrated perspective, through the lens of integration. And it's not just the water cycle. I think we have to look at solids and we have to look at energy. We have to start thinking about, when we look downstream up, that everything has got value to it, and how can we extract that value? But, water utilities are large organizations. And, for them to transition, it's hard. There's a lot of legacy infrastructure, there's a lot of sunk costs, there's a lot of sort of irrational connection with this grey, hard infrastructure, and change will be difficult. And I think the key for us is to do more research on transitional pathways. And it's the pathways in terms of technical transitioning. How do we physically transition infrastructure from where we are to a different paradigm, rather than just assuming it has to stay the way it is? We need to look at transitioning our perspectives away from sort of just public health, but in terms of the productive use of water, and transitioning the culture of utilities so they embrace innovation much, much more. That will conclude my presentation. Thank you all. Thanks very much.
I think we have time for a couple of questions, if there are any.
Carla, do you want to stand up there? Oh, sure.
Hi, Don Phipps with the Orange County Water District. Excellent presentation. Thank you very much. One question I have for you, maybe you brought this up and maybe I just missed it, but in developing a modular and somewhat decentralized approach, how do you deal with the water quality and the regulatory side of the business? You kind of, as you transition away from a centralized system, you now develop more decentralized places that need monitoring, that need water quality assurance. And how does that, what's your experience, at least in Africa, how has that been dealt with?
I think, well, two things. I think you're right. And, when we talk about a clustered approach, we're really also, the argument in terms of size is as small as can be, but as large as needs be. And large as needs be is really about professional management, okay? So we're not talking about sort of on-site type treatments, but systems that are large enough that they can be managed. In terms of the regulatory framework, I think that we're dealing with environments where they don't have mature institutions at the moment, And so we're learning a lot from the mistakes made by the developed countries, and we're starting to ask ourselves, have we created this fear of water that's a little bit, not really shouldn't be there, and can we be much more intelligent about the way in which we use water? So you're seeing, for example, in Uganda through the National Water and Sewerage Corporation, real deep thought about trying to develop appropriate regulatory framework, and also in South Africa, which is really ahead in a lot of this, and it's sort of already started to deregulate. So I think you're going to get a different landscape in some of these developing countries that doesn't have the historical baggage that we've had, where everything was around public health, and it was really very much around fear. And I think they're going to be much, much more practical.
So, Mark Wisner from Duke University. Thank you for your presentation. I'd like to have your university administration talk to mine because we've got way too many deadlines and urgency.
I'm sorry.
No, I was curious, in the scenario you presented for the two growth scenarios, I think it was in Uganda, and you looked at reductions in cost with the cellular scenario. So what was behind those reductions? Where were you finding the most reduction in cost in going to that scenario?
I think the main reduction was in terms of the importation of water. The energy cost to move water long distances. That's the main. And the systems that we were looking at were essentially sort of gravity-based systems for the reuse and recycling, around what's called the DWATS approach. Yeah.